Triangle similarity theorems. There are three triangle similarity theorems that we will learn today. The first is angle-angle similarity. So what this says is if two pairs of corresponding angles are congruent, the triangles are similar. So we no longer have to check to see that all of the angles are congruent and all the sides are proportional. What we're saying here is that if we have two triangles and two corresponding angles are congruent, then the triangles are similar. The next is side-angle-side similarity. So if two sides in one triangle are in the same proportion to the corresponding sides in the other, and the included angles are equal, then the triangles are similar. So let's simplify that just a little bit. If we have two sides that are proportional, and the angle in between those two sides are congruent, then the two triangles are similar. And lastly, we have side-side-side similarity. If the lengths of the corresponding sides of two triangles are proportional, then the triangles are similar. So if all three sides are proportional to all three sides of the other triangle, then the two triangles are similar. So let's begin with our first example. So here we have two triangles, and we need to see if these two triangles are similar. And if they are, we're going to state the theorem that says so, and then we're going to write a similarity statement. So as we look at these two triangles, what do we see? Do we see angles? And by that, do I mean, do we see information about angles? Do we see information about sides? Or do we see information about both? Well, here we don't have any information about angles, but we do have information about three sides. So that tells us that our only possible option at this point is side-side-side similarity. But we can't just say that right off of the bat. We have to see if those three sides are actually similar. Are actually proportional. So let's go ahead, because we know how to see if sides are proportional. And I'm going to number numerically. So this will be 1, 2, 3. And then 1, 2, 3. Okay. So now that we've done that, we're just going to choose a triangle to be the original and the new. All right, and now we need to set up our fractions. So we got our 1s, we got our 2s, we have our 3s. So, that'll be 42 over 49. And then the 2s, 66 over 77. And the 3s, 78 over 91. So 42 divided by 49 equals 0.857. So remember, you want to make sure to write out at least 3 decimal places, so that way you don't get confused when the numbers look kind of alike, but they're not all the way alike. So write out enough numbers so that you can actually tell the difference between the numbers. And then finally, 78 divided by 91 is also 0.857. So what this tells us is that the sides are proportional. So just based off of that alone, we can say that yes, we have side-side-side similarity here. And now we just have to write our similarity statement. So let's talk about how to write the similarity statement when we're not given any information about angles. So here, the first letter that we have is T. So as I look at T, my question for you is, what two sides are on the, what two sides is T in between? So we see T is in between side 3 and side 2. So I'm going to come down to my other triangle. I'm going to find 3 and 2. What letter is in between 3 and 2? That's F. So F corresponds with T. What about U? U is in between sides 2 and 1. So I'm going to come down and I'm going to find 2 and 1, and that is angle G. And finally, the last letter left is H. So triangle TUV is similar to triangle FGH. Example 2. what information is given? Do we have sides? Do we have angles? Or do we have both? Well, here we're only given information about angles. How many angles in particular? We have 2 angles. So at this point, our only option is angle similarity. So let's check to see. Remember, this angle should be congruent to some angle in this triangle, and this angle should be congruent to some angle in this triangle. So here we have 41 degrees. Do we see 41 degrees down below? Yes. So 41 matches with 41, and then we have 83 that matches with 83. So we can safely say that these 2 triangles have a similarity. Sorry. All right, so we can safely say that these 2 triangles have angle similarity. Now to write our similarity statement. So Q is 83 degrees. And we also have 83 degrees here. That is U. So Q corresponds with U. R is 41 degrees. 41 degrees is V. So R and V correspond. And then finally, the last letter is W. So that is UVW. And then finally, example 3. So example 3 is a little different because we have our triangle. You have one triangle within another triangle. All right. So let's make sure that we can see both triangles. So I'm going to highlight one in red. And then I'm going to highlight the other in blue. So we can clearly see our 2 triangles now. Now, it is my suggestion that off to the side, you always redraw the triangles when they are, combined within each other like that. So let's go ahead and label. So for my smaller triangle, my top vertex is B, the right is U and V. And then for the big triangle, we have B, C, and D. Okay, so let's start filling in information. So what is the length of the long triangle? What is the length of this side of the big triangle? Do we see that that is 66? What about this side of the small triangle? That is 9. Okay, now how will we figure out the length of this side of the big triangle? Well, do we see that this part is 9 and this part is 45? And this is completely off scale, by the way. But anyway, so this part is 9 and this part is 45. So in order to figure out the length of the whole thing, we would do 9 plus 45, and that would give us 54. Now, what about here? And let me erase that. I kind of made a stray mark there. Okay. And what about this part right here? If we want to find this part of the small triangle. So if we know the length of the entire side, and we also know a part of the side, we would need to do 66 minus 55, and that'll give us 11. So the length of this part is 11. So there is one more piece of information that we have here that needs to be transferred over here. Do we see how both triangles are sharing angle B? Well, if they are sharing angle B, if they have that same angle, that means these angles are congruent. So B corresponds with B. B is congruent to B. So now looking at the information that we have 2 sides and an angle for each triangle. So we're going to check to see if this has side angle side similarity. All right, so in order to do that, we already know that one of the angles is congruent. So now we need to check to see that the sides are proportional. So let's go ahead. We number in numerical order. So we can do 54 over 9, and we can do 66 over 11. 54 divided by 9 will give us 6. 66 divided by 11 will give us 6. We do have the same number. So yes, we can say that this has side angle side similarity. And now to just write our similarity statement, we know that angle B is between, this triangle, angle B is between 1 and 2. So what's between 1 and 2 here? B as well. C is between 2 and nothing. What's between 2 and nothing here? That is U. And then finally, D is between 1 and nothing. So 1 and nothing, that is V.